right, hi there. Grab your spiral notebook and a calculator, and at the top of a new page, I want you to label it trigonometry ratios. Okay? We're going to just quickly review the three trig ratios, sine, cosine, tangent, and then this little video will just help you be able to complete the homework that you missed in class. So the three that we talked about in class was the sine function, and then we reviewed the cosine function, and finally the third function is the tangent function. All right, so with the sine function, we need to understand with these that we have to have a right angle. All right, so once we have a right angle, we are going to label one of the acute angles. So if this is the right angle, then either this angle or this angle is the acute angle. So I'm going to just go ahead and choose this one. And a common symbol that you're going to see is called theta. It's a Greek symbol. And a lot of times they use this little symbol to denote the angle. And what we want to review here is that when we're using the sine function, we need to identify the opposite side. Well, the opposite side from theta would be right here, okay? And that side right here is going to be the opposite side. And we're also going to use the hypotenuse. Well, the hypotenuse is easy to pick out because the hypotenuse is always going to be across from the right angle. Okay, so the hypotenuse is going to be this side right here. And when we go to write the function, we would say that the sine of the angle, theta, is equal to this ratio, the opposite side over the hypotenuse. And what this is going to be used for is we are going to use this to set up an equation that can be used to solve for a missing side or a missing angle. So let's set up another triangle and review what the cosine function looks like. So cosine, if we again denote this to be theta. Now, really, I need you to understand that it doesn't really matter which acute angle you label theta. I'm just trying to be consistent. So this time for cosine, we use what's called the adjacent side. And the adjacent side is the side that helps form this angle theta. Okay, the opposite would be right here. This is the adjacent side. But the hypotenuse, again, is always easy to pick out because it's across from the right angle. And so what we say is that the cosine of the angle equals the adjacent side over the hypotenuse. Finally, our third triangle we're going to use to set up the tangent ratio. We're going to pick an angle again, theta, but this time for tangent, we are going to use both the opposite side and the adjacent side. So tangent's actually the only one that does not use the hypotenuse at all. So that was the opposite, this is the adjacent. And the tangent ratio is equal to opposite over adjacent. All right, so let's just do a couple of examples to review this, because what you're going to see in your homework is we are just going to simply find a couple different sine, cosine, or tangent ratios. So I'm going to say we're going to find tangent of angle A. And so given this triangle right here that we need to draw, try that again. That was not a very good right triangle. All right, so given this right triangle, I am having trouble with this. All right, one more time. Okay, nope. We'll just go with that. All right, given this right triangle, I'm going to label this A, B, and C. And so the side lengths that are given is going to be 5, and the hypotenuse is 13. All right, so here's what we need to do. We need to find this missing side, okay? So if I'm talking about, let's talk about why we need to find this missing side. So here's angle A. I'm going to put a little arc or a little symbol that's going to help me understand that this is my reference point. Well, when I look at this, 5 is the opposite side, 13 is the hypotenuse, and the problem is that the tangent of A is defined as being the opposite over the adjacent. Well, the problem is I don't know the adjacent side, and we need to solve for it. So what we need to do first is we need to use the Pythagorean theorem. And the Pythagorean theorem will help us find that missing side. So if we say x squared plus 5 squared equals 13 squared, we can then set up a little equation. 5 squared is 125 and 13 squared is 169. I can then take 169 minus 25 and I get 144. Right, so if I minus 25 from both sides, we get that x squared equals 144, and conveniently, when we square root 144, we get that the missing side length is 12. And you don't always get a whole number, just so you know. You might get a radical too, and I think we'll see that in our next example. So I'm now going to label this side 12, and this is what we would call the adjacent side. So now let's go set up the tangent ratio of angle A. We would say tangent of A is equal to this opposite side, which is 5, over this adjacent side, which is 12. And just like that, that is going to be our answer for now. Okay, and we'll do this, we'll work with this more, and we'll eventually start solving equations, but for now we're just practicing setting up the ratios. We're going to do one more example, because I did 3 examples in class, but I'll cut this down. We'll just look at one more example and then give you a chance to practice this concept in the homework. All right, suppose we need to find the cosine. Let's do this. Let's do cosine of theta. Okay, so this time I'm going to draw a triangle, and we're going to label this side 3 square root of 7. Nope. We're going to label this 4, and we're going to label this square root of 7, and we're going to denote theta as being this angle. So this picture right here, this is what you would be given. Okay, so when I look at angle theta, I'm going to label this is the opposite side, this is the hypotenuse, and again, I'm missing the adjacent side. And so I'm going to have to use the Pythagorean theorem to find the adjacent side. So let's set up the Pythagorean theorem. This is going to be, we'll just call this x for now. X squared plus square root of 7 squared equals 4 squared. All right, well, when I take x squared and I bring that down and I take the square root of 7 squared, we've seen this happen a lot where the square root and the square cancel each other out, and 4 squared is 16. Okay, and when we continue, I'm going to minus 7 from both sides. X squared equals 9. When we square root both sides, we see that x equals 3. And so that this missing side length right here is going to be 3. All right, so let's set up our ratio. We know that cosine of theta is defined as being, right, now I don't have it in my frame, so I'm going to rewrite SOHCAHTOA, and this reminds me that cosine is the adjacent side over the hypotenuse side. And so the cosine of angle theta is the adjacent side 3 divided by the hypotenuse 4. And that's how I would leave the ratio. Okay, so hopefully this helps give you a quick little refresher on how to set up sine, cosine, and tangent ratios. And you can then work on the assignment that you missed in class. Let me know if you have any questions. Thanks, bye.